Yeah, Assalamualaikum and very good morning. Very good evening to everyone. I'm Wan Shakira Rosla Hassani, a moderator for our webinar today. And this is our fourth series 4 webinar, a free webinar organized by Malaysia Disease Modelling Expert Group, MDM together with Digital Health Science Unit, DHSU, School of Medical Science, University Science Malaysia, and also was supported by Malaysia Epidemiological Association, MAE, and also PEAKK, Persatuan Anggota Kesihatan Kelantan. So today our webinar title is Beyond Simple Regression, Unlocking Multi-Level Model with lme4. So we are very fortunate today to have our speaker, Mdm Nur Hidayah Zainal. She is a PhD student in Biostatistics from School of Medical Science, University Science Malaysia, under supervision Prof. Kamarul Imran Musa or Prof. Kim. So Mdm Nur Hidayah is very well with this kind of model, MLM modeling, where she used this analysis as a part of their thesis project. So before we start, a quick reminder for everyone to fill in our attendance sheet. We already put the attendance link in our chat box. So we have 2 CPD point, MMA CPD point, and also USM CPD point. Okay, for USM staff, kindly use the USM passport, the apps to scan the QR code. Okay, so without further delay, I would like to invite our speaker, Mdm Nur Hidayah, to share this very interesting topic. So over to you, Hidayah. The floor is yours.
Thank you, Shakira. Can you hear my voice?
Yes.
All right, great. Can you see my slide now?
Yes, clear.
All right, great. So now, we are trying to organize these things so it is not messy, right? So, well, Assalamualaikum everyone, and good evening. I am really thrilled to be here with you all today. My name is Nur Hidayah Zainal, and I'll be your speaker for today. Well, I'm going to be sharing and talking about Beyond Simple Regression, Unlocking Multi-Level Models with lme4, use case in clinical decision making among nurses in Malaysia. So to guide our discussion today, I'm divided my time into 3 parts, all right, 3 main parts. The firstly, we will begin with a foundational overview of multi-level models, and next I will highlight the key benefits of leveraging the powerful lme4 package, and finally we will move to a hands-on demonstration of how to code by using lme4 in R. Well, my hope is at the end of my talk, everybody here will walk away with a basic grasp of multi-level modeling by using lme4. So now, what is multi-level model? Multi-level modeling, also known as hierarchical linear model or mixed effects model, analyze data with a hierarchical or nested structure. This technique accounts for data points grouped or clustered within multiple levels, such as students within school, repeated measures within subjects, or what we have here, nurses on level 1, within hospital on level 2, and further nested within states and region on the level 3. All right. So this is what we call as a 3 multi-level modeling. It also allows for the modeling of variation at different levels of the hierarchy, capturing both within group and between group variability. For example, when the individual nurses scores are collected from multiple hospitals at one point in time, then observations within these hospitals are more likely to be similar. The nurses from different hospital might perform differently, while the performance of nurses from the same hospital might have some similarities. So if you are still fitting a regular regression to model this kind of relationship between nurses cross and some predictor variable X, then we will be discounting the effects of hospital level variables such as the type of patients, the complexity of cases, or specific demands of different hospitals. With a simple regression model, actually, how can I say this? Like there is no way we can estimate how much variation is caused at the nurses level and how much at the hospital level and might as well at the regional level. So, well, let's imagine of our beloved country, Malaysia, with its diverse regions and states. We have a rich area of hospitals serving our communities, including general hospitals, district hospitals, private hospitals, and educational hospitals, just like different flower beds that have varying soils and sunlight. These hospitals operate within distinct environment. The regional level factors can be linked to the overall climate and soil conditions. This could be the socio-economic development such as poverty levels, access to quality education and healthcare resources can impact the nurse's ability to provide optimal care in that particular region. The culture influences such as local beliefs, values, and healthcare seeking behaviors may have an impact on the patient-centered care. The healthcare infrastructure, like the availability of specialized services, transportation networks, and telemedicine facilities, could impact the nursing performance. On the other hand, the hospital level factors are akin to the specific characteristic of each flower bed. The hospital types such as general, district, private, or educational might have different resources, different patient population, and also different organizational structures that could impact on the nurses' clinical decision-making process. The staffing levels, including nurse to patient ratios, availability of specialists, and experienced staff actually play a crucial role on nursing performance. The hospital culture, such as leadership style, the teamwork, and the emphasis on continuous learning and professional development also could impact nursing services. So all these kind of factors from different levels might have different impacts on the outcome variable. Therefore, to fully grasp these complex interactions, a multi-level analysis is really essential. The lme4 package will be a valuable tool to analyze how these regional and hospital level factors influence the clinical decision making of nurses across Malaysia. It accounts for the nested structure of the data, such as nurses nested within hospitals and further nested within regions, and also it's allowed to model the variation in decision making skills across different hospitals and regions. And also, it's could identify which factors at the regional and hospital levels that have the most significant impact on the nurse's performance. So for further details, you can check on the PDF link that's available on your screen. All right. So now, before we proceed in R, I'm just going to give you an overview of what the syntax looks like in R, all right? So for the mixed model notation, it's important to identify 4 different elements, all right? First one is outcome variable. Second is fixed predictors. The third is random predictors. And lastly is cluster variable. So the syntax for a very simple model might look like something like this. All right, so we got y tilde a plus x vertical pipe id comma data equals d. Y right here is your outcome variable, just as it is with a regular regression model. A right here is where you put the fixed effects, and x right here is where you put the random effects. The id is where you put the cluster variable. So notice that all the random effects also have fixed effects, and that's important. Every time you model a random effect, it also has to have a fixed effect. And let's look at another model, the multiple fixed effects. So here we've got A1 and A2, both of which are fixed effects. And because they are fixed effects, notice that neither A1 nor A2 are within the parentheses because, again, they are fixed effects only. And then the X is the same as before. It's got a random effect and it's also got the fixed effects. How about multiple random effects? Let's check it out. So here we've got only one A variable and we have S1 and S2. And notice that we have S1 and S2 both within the parentheses and outside the parentheses, because again, let me emphasize, every time you model a variable with a random effect, it also has to show up in the fixed effect area too. All right. What about multiple fixed and random effects? It might look like this, where you got A1 and A2 both fixed effects and S1 and S2 both random effect, but again it shows up in the fixed effect area too. What if we have a model with no random slopes? So we might have a model that look like this. Y tilde A plus parenthesis 1 vertical pipe ID. So why is that 1 there? Well, really the 1 is there because if you have no random slopes and you just leave that blank, it's going to get you an error. And most importantly, that 1 tells R that you want the intercept to be random. All right. What if you have a model with no predictors at all? We usually call it as a null model, and the syntax would look like this, right? While theta 1 plus 1 vertical pipe ID. This basically telling the model to fit a mean for each of the cluster. You may use this just as a baseline model, so you can start to get your R square and your RCC. All right. So, yep. I guess now let's jump to the R and let's do some coding here. Wait, I stop sharing these things. And okay, now I'm sharing my R. All right. Okay. So, could you see my slide? Sorry, my art now, Shakira?
Yeah.
Okay, yeah. All
Okay,
right.
yes.
Okay,
You can
great.
see.
Great. Okay, now let me put this. Okay, now. All right, this is the R interface, and we're going to fit some models in here. Let me first explain regarding the variables that we're going to use for today. Here we've got, we have CDM, clinical decision making score, as the outcome variable. And for the level 1, the individual level factors, we have age, gender, education, experience, post-basic, continuous professional development or CPD point, the nurse's knowledge, and also the critical thinking. For the level 2 hospital level factors, we have unit, department size, hospital settings, and hospital size. And for the level 3 regional level factors, we have state and state size. And in order to proceed with this coding session, we need to install the required packages, and we also need to call and load the library. Here we will use lme4 for multi-level analysis, lme4 test to get the p-value estimation, performance to get the ICC, and rec helper to plot some interactions. All right, so I just click on here. Yep, it's functioning. Next, we need to import our data. Here I'm using the read Excel function to import my data. And now, we need to combine hospital and department ID within each region to create a unique identifier for hospital department. So here I'm using paste function to combine the hospitals with the department ID. All right. So, okay. Next, we need to select our variable. So I just click down here. All right, so if you could see here, we have a ID, hospital department that we just created just now, department, hospital, age, gender, education, experience, post-basic, CPD points, hospital types, hospital size, department size, unit, state, region, state size, our outcome variable, clinical decision making score, critical thinking score, and also nurse's knowledge. So now I think we are all set and ready for our coding stations. Well, in this brief webinar, I will walk you through how to run multiple models with the lme4 package. I won't have enough time to go into the details of the results, so we will focus on the modeling process only, all right? So firstly, here, for 2 multi-level models, we will run a null model like what we have here. For example, a question on what is the average score of the clinical decision making for the entire group as well as for each individual. So we are going to start with a baseline model by using this syntax. Basically, there are three components. The first one is DY or outcome variable. Here we've got the clinical decision-making score. And then what comes immediately after the CDMS is the fixed effects. So when we say 1, we are telling R to fit an intercept only model, all right? So, and lastly, in this parentheses here, we put our random effects on the left side of the vertical part and also our cluster variable hospital department on the right side of the vertical part. So we just run this model, wait for a while. Okay, here's the output. So here we've got the AIC and BIC. And under random effects, we've got two random effects for two multi-level models. We have hospital department and the residual or nurses within hospital department, right? And down here, we've got our fixed effects, the parameter estimates, and also our p-values. All right. So actually, by using this null model, we're able to calculate the inter-class correlation or ICC by using the performance function, all right? So now I'm using this syntax, right? Let's run. Wait for a while. All right, so look at this output. Here we've got the ICC value with which is mean that the correlation of CDM among nurses in the same hospital department is approximately around 0.273, and this is within the acceptable value range. Therefore, it means that this model is worth pursuing with multi-level model. All right. So next, we move to the random intercept model. Here, we might want to include fixed effects. So we simply add them regardless of whether they are on level 1 or level 2. For example, what we have a question on, do the clinical decision-making score is predicted by the nurse's individual level and hospital level variables. So here we've got the nurse's knowledge, age, gender, education, experience, post-basic, CPD, and critical thinking for the individual levels. And also we've got the unit, department size, hospital settings, and hospital size for the hospital level variables. So I just click on here, wait for a while. So look at this output. Here we've got our AIC and BIC. And down here under random effects, we've got two random effects for two multi-level models. We've got the hospital department variance and also the residual. This is within hospital department. Under the fixed effects, we've got our parameter estimates and also the p-value for each variable or fixed effects, all right? So if you could see, we've got the nurse's knowledge skills that is significant. The critical thinking skills also significant. Both of these from individual level factors, and also we've got hospital settings that is significant. All right. So now we move to the random slopes. Right. Now we might want to add. Now we might want to add a random slope just to see if the clinical decision-making score is predicted by the variables at both individual and also hospital department level. In this case, we want the level of nurses' knowledge and experience to vary between both individual level and department level. So if you could see here, we put clinical decision-making as the outcome. The fits, we put the knowledge, experience, and hospital settings. And for the random effects, we put the knowledge and experience. So sometimes while coding, we would be facing some issues like a different scale. And in order to solve these issues, I'm using the grand mean centering, which simply refers to the practice of subtracting the mean of a variable from each individual value. All right, it enhances interpretability and improves numerical stability and can reduce the correlation between predictors and random effects. So we're gonna use this grand mean centering by using this command on nurses' knowledge and also critical thinking. All right, so we just run this. Yep, it's working. Just like I mentioned before, here is our random slopes. We put the nurses' knowledge, experience, and hospital settings on the fixed effects, and nurses' knowledge and experience as the at the random effects. All right, just run this model. Wait for a while. Here is the output. So we've got our AIC and BIC under random effects. We've got our random effects, two random effects, definitely for two multilevel models. Just want you to see down here under hospital department, in addition to the random intercept, we've got our slope, the nurse's knowledge and experience, and also we have our what we call this a correlation between random intercept on level 2 and also random slopes on level 2 here. Under fixed effects, we've got our parameter estimates and also the p-value. All right, so far we have finished coding with the 2 multi-level modeling. So now we extend to the 3 multi-level model. Hope you are still here with me. So for 3 multi-level models, basically we have 2 options to code 3 multi-level model. You may choose the short one here, region stroke hospital department, or the longer one here. We explicitly define both parts. We define here the random intercept on the region level 3, and also here between hospital department within a region level 2. Right? So both codings may lead to the same results, but there are some analysis that we will need the longer code. I will show you later. Right? So for the baseline, I'm going to run this code, the short version and also the longer version for comparison. Okay, now let's see. So for the 3 multi-level models, for the random effects, we've got 3 random effects for 3 multi-level models. We've got the first one is region, and then we've got the variance for hospital department within a region, and also the residual nurses within hospital department within the region. So 3 random effects. All right. Let's just focus on hospital department within a region. The variant is 12.436 for the short version. Let's move to the longer version and look at this. Also, we've got 12.436. What about the region? We have for the longer version 3.814. And look at the short version, also 3.814. What about the residuals? We've got here for the short version 38.718. And for the longer version, also 38.718. What about fixed effects, parameter estimates? So here we've got the random intercept is 36.076 for the longer version. And look at here, 36.076. All right, so basically all the same. Okay, I guess we can move to the random intercept models. So now here we might want to include the fixed effects. So we simply add them regardless of whether they are on level 1, level 2 or level 3. For example, we have here a question on do the clinical decision-making score is split by the nurse's individual and hospital department variables. So here we put critical thinking and nurses knowledge from the individual levels, and then we put hospital size from the hospital variables. Let's run this code, wait for a while. So here we've got the AIC and BIC, and we have our random effects, 3 random effects for 3 multi-level models, definitely. Here we have our region. Here we've got the hospital department within a region, and also we've got the residual nurses within hospital department within a region. Now here under fixed effects, we've got the parameter estimates and also the p-values. So now we move to the random slope models. Now, now we might want to add a random slope. In this case, we want the level of critical thinking to vary between regions, and to define these random slopes is only relevant for the region and not for the hospital within the region. We need the longer notation. All right. So here I have already added the critical thinking score on the level 3, whereas here there is still random intercept only on the level 2. All right, so let's run this model. All right, this is also this is our output. Here we've got AIC, BIC for comparison. Under the random effects, we've got 3 random effects. Yep, for 3 multiple models, but I want you to focus on the region. In addition to this random intercept, we've got our random slopes, critical thinking score. All right. Here we also have correlation between random intercept on level 3 and also random slopes on level 3. Right. All right. So now down here under fixed effects, we've got our parameter estimates and also the p-values. All right. In order to explain this variation, we could add a cross-level interaction. And in this case, we might want to see cross-level interaction between experience here with from level experience from level 1 with hospital settings from level 2. This is what we call cross-level interaction. In addition, with another 3 interactions, we've got nurses knowledge with experience, critical thinking with nurses knowledge, and also critical thinking with experience. All right. So we just run here, wait for a while. So here we've got the AIC and BIC. Down here we've got our random effects, 3 random effects for 3 multiple models, the region, hospital department within a region, and also the residuals. Down here we've got our fixed effects, the parameter estimates, and also p-values. I just want you to see down here, because this is a cross-level interaction model. So here, and okay, if you could see here, okay, we can conclude that the effect of nurses' experience on clinical decision making is different depending on the hospital settings, because it is significant. All right. So now, to better understand this interaction, I think it's useful to plot simple slopes, and for that we could use a graph model. Graph model function from RegHelper library. By using these codes, we put the we put the clinical decision making score, our output. For the X we put the experience, nurses experience, and last we put the hospital settings, district, and also general. Right. So we just run this model. Wait for a while. All right. So this is our graph. So look at this graph. Here we can see for the district hospitals, the red line here indicates that the nurses' clinical decision making score increase as their experience increases. Whereas for the general hospitals, by using this green line, the clinical decision making score among nurses more or less stays the same regardless of their experience. Well, I think we've done with our coding.
Dia booking enggak lah. Nanti mana? Ada 20.
Stop sharing this and get back to our Canva.
Sorry, orang suka chat ni kau tak pernah aku tengok. Ya, tak tahu orang nak dah. Sebab ni tak ada orang mana tak ada sana.
Okay. Shakira, can you see slide?
Yes.
All right, great. So, as a conclusion, we have explored the implementation of multiple models using lme4 package in R. This powerful tool allows for the analysis of data with hierarchical structures, also enabling researchers to account for variability at different levels. As a take-home message, I encourage you all to consider understanding the mixed model notations and the steps you could as you use this multi-level analysis in your research. Let's work together to achieve better results by accurately capturing the complex relationships between levels in our data and drawing more reliable conclusions. So I guess that's from me, a very quick overview of how to use the lme4 package for multi-level modeling. We didn't have time to dig into the results for today, but hopefully this gives you a good starting points for your own analysis. Feel free to ask any questions you might have now, or maybe you can reach me out later if you have any further questions through my emails provided on my last slide. All right. Yep. Before I leave, I would like to thank our moderator, Shakira, our Dr. Shakira, also our organizers, the Malaysian Disease Modeling Expert Group, and the Digital Health Science Unit for having me today. All right, get back to you, Shakira.
Okay, thank you, Nur Hidayah, for a very insightful presentation. So now it's time for our Q&A session. So feel free, anyone who want to ask, you can unmute and ask the question. Maybe we can have one to three questions. Anyone? Or you can type in our chat box. So far, there is no questions yet from participants. Anyone to ask? I think we have over 60 participants here. No one? Okay, maybe one question from me. I think for beginner, just heard about this MLM modeling. Maybe they might be confused how to decide to use either random intercept or random slope model. Maybe just give a very simple example.
All right. All right. Thank you, Shakira. Question from you. All right, definitely. Usually I'm choosing between fixed effects and random effects actually by looking at our research question. Also by looking at our objectives, and also the structure of that, like what we have here, hospitals and region. I'm looking at the structure to put which one in on the random effect and which one on the fixed effects. All right. So I think, is it?
Yeah.
Okay. All right.
So anyone, anything who want to ask? Okay, so if you see at our chat box, we already share attendance links. So kindly fill up this link to claim for MMA CPD point. All right. Here. So because it's, we have a time. It's 9:30. Okay. Anyone?
I have a question.
Okay.
Actually,
Right.
maybe because we usually don't use MLM lah. So maybe this is just a basic question I want to ask is how you choose either you want to use the random or fixed effects, or just the model will just make for you to decide for the random and fixed effect. That one is for the first questions. And then the second question is that if the level, if the like district, and district, sometimes the population is different size. Is the different size of the unequal size of the sample or the level will affect the outcome, the model.
What is the first question? Sorry.
The first question is about the random and fixed effects.
Just like the Shakira asking just now, is it?
I think Dr. Shakira, they mentioned about the random slope. I think doesn't say something about the fixed effects. I am also not familiar with the fixed effects or the random effect for MLM model.
All right. Thank you. All right. How do I choose between fixed effects? Fixed effects and random effects. For the fixed effects, usually we put the individual level factors. All right, like what we have here, nurses. We have the experience, the age, knowledge score, critical thinking score, all about the nurses, individual nurses, and for the also we put the second level of variables, like hospital department, like a unit, hospital settings, and the third also we put the third level, level 3. Level 3 variables, like a state and state size. And for the random effects, we actually we think of our research question, what we want to know, all right? What we want to know. And this is the first draft I did, right? So I want to see if the region, is it the experience might affect nurses on different region, then I put it, all right? Then after that, after we run the model, we run and rerun the model, and we look at the output. Sometimes what we put as a research question before is not is cannot be used when the outcome when we produce the outcome, the outcome will the AIC and BIC also, the p values will not be significant, so we need to drop the I mean the random effects, the variables from the random effects, and rerun again, and then rerun again. All right, for so many times. I did it for so many times to get around 24 models. All right, that is fit for these multi-level models. All right, did I answer you, Mr. Muhammad Azimullah, doctor?
Yes. Fantastic.
Yeah. What the second? Sorry, second.
Okay, for the explanation. Second question is about the I just think about if the what we call the sample for the level is unequal, meaning for example, like district sometimes there are too dense population, and then for the other district is less dense population. So is it really affect the model?
Right. Great. This is a good question, actually. We begin this with sample size calculation, and we choose the using multi-stage sample sizing. Wait, if I have this here. Multi-stage sample sizing. So we choose it very carefully from the region level, and then from the also the hospital we put in R, and we choose it randomly, and also we ensure that from every single department we choose the same equal size of nurses. For example, if we said from hospital department A, we choose 20 nurses, and hospital department B, we also choose the same 20 nurses. And yeah, I think that's why we got around 800 nurses for 20 hospitals around Malaysia. Is it, I'm answering your question, Mr. Dr. Azimullah?
Yeah. Okay, thank you, Hidayah. Okay.
All right.
Okay, we have another one question from Dr. Kusaifullah.
All right.
Dr. Ku asked about, I missed a part of model performance. How to interpret the performance? Do you mean performance BIC or AIC performance?
Dr. Kusaifullah. Maybe you can unmute.
It's okay, just answer. How to interpret AIC, BIC.
All right. Okay. All right. Okay. If you remember my R just now, the output, we've got the AIC and BIC, and we use it as the comparison. The first step to compare, we use the AIC and BIC, and to choose the smaller one, the smaller AIC BIC, the better one. We choose that one. All right. We compare all the models. All right. But actually, advice from my supervisor, actually we didn't choose. We put all of them as long as it reliable, as long as it's valid. All right. And it's significant. So we didn't choose. Actually, we put all the variable in my thesis. Is it okay, Dr. Saifullah? Am I answering your question?
He asked the chunk after AIC/PIC, the code you use,
Oh,
package
the
performance.
performance package. Alright.
Okay.
Okay. The performance package actually is to calculate the ICC. Alright, intercorrelation. We actually need to calculate the ICC in order to know is it reliable or valid to continue with multi-level modeling. Because sometimes if the ICC is not in the acceptable value range, we cannot proceed with this multi-level analysis. So the chunk after IC the code is that's my answer. We will use the performance. How to interpret is by you must know the range, the value range, acceptable value range of the ICC is less than 1, I mean 100%. So just now we've got around 0.2, which is means that 27%. So it's acceptable in the range of the acceptable value. All right, Mr. Dr. Kusaifullah.
Okay, thank you, Dr. Ku, for asking. So there any other question? If no, sorry? Anyone? Okay. I think there is no question. So before we end of our session, once again, I would like to extend heartfelt thanks to our speaker, Nur Hidayah, and also special thanks to organizer from MDMEJ, especially Dr. Hazlino, and also Miss Alia from Digital Health Science Unit. And thank you so much. And I think Prof. King's not with us today, but I would like to thank to Prof. King. He is the one who initiated this webinar. So maybe next we will have another series of webinar with interesting topic. So we look forward to see you at our future event. And so our session is end today, and have a very weekend, everyone, and thank you again for joining us. Don't forget to fill and submit the attendance forms. Okay.
Thank you,
Everyone.
Thank you, everyone. Thank you.